Saturn is the second of the giant planets. Like Jupiter, it's a gaseous ball whose rapid rotation, once every 10 hours, makes it bulge at the equator. Atmospheric features on Saturn are much less obvious than they are on Jupiter. In this picture, false colors have been used to exaggerate slight differences in brightness to show the bands in more detail. Very few oval cyclones can be seen.
The Cassini spacecraft has been studying the Saturn system for almost 7 years, sending back data and amazing images of the rings, icy moons, Saturn's magnetosphere, Titan, and Saturn itself.
We've always thought of Saturn being this serene body. It looks like a pearl in the sky with different hues to it due to different types of clouds. What we're seeing is that if you go through those hazes and get down to the depths of Saturn, you find a roiling atmosphere. And the cyclone is probably one manifestation of this dramatic dynamics. We did realize that there was a cyclone on the South Pole a year ago. What was the surprise was we see essentially the same type of a feature in the North Pole. The North Pole has a hexagon around it. You know, these cyclones on Saturn are huge. You can fit at least one Earth in one case and two Earths in another case inside these things. And they have powerful winds near the center of about 300 miles an hour. So in a lot of ways, these are the most powerful cyclones ever seen. Both Earth and Saturn work on the same laws of physics. But the Earth has this vast reservoir called an ocean, which can take up heat and absorb it from the sun, and then release it under the right conditions to create a hurricane. On Saturn, we have internal heat deep down. And it's being powered by processes that are happening deep into the atmosphere of Saturn. What it shows us is there's some bizarre physics going on Saturn. That is, it's drawing large amounts of energy from the inside of Saturn to power these storms. We're talking again about a storm system that's about 20,000 kilometers across, or even larger. That's a gigantic storm system, so it's the largest storm system of this type we've seen anywhere in the solar system. And now we've seen two of them at both poles. It shows us that Saturn is special and that we should keep studying it.
Last year, amateur astronomers turned citizen scientists aimed their astrophotography equipment at Saturn and discovered a new storm. The next day, they sent their images to Cassini scientists, and Cassini's instruments studied the storm too. When you look at Saturn through a telescope, you may catch a glimpse of the storm's whitish cloud bands circling the planet.
Researchers using the NASA ESA Hubble Space Telescope recently took advantage of a rare opportunity to record Saturn when its rings are edge-on, resulting in a unique movie featuring both of the giant planet's poles. Saturn is only in this position every 15 years or so, and this favorable orientation has allowed a sustained study of the two beautiful and dynamic aurorae, Saturn's own northern and southern lights. Hubble has now taken a fresh look at the fluttering aurorae that light up both of Saturn's poles. These recent observations go well beyond just a still image and have allowed researchers to monitor the behavior of both Saturn's poles in the same shot over a sustained period of time. The movie they created from the data collected over several days during January and March 2009 has aided astronomers studying both Saturn's northern and southern aurorae. Given the rarity of such an event, this new footage will likely be the last and best equinox movie that Hubble captures of our planetary neighbor. A natural consequence of the shape of the planet's magnetic field, a series of invisible traffic lanes exist between the two poles, along which the electrically charged particles are confined as they oscillate between the poles. The magnetic field is stronger at the poles, and the particles tend to concentrate there, where they interact with atoms in the upper layers of the atmosphere, creating aurorae, the familiar glow that the inhabitants of the Earth's polar regions know as the northern and southern lights. The northern auroral oval is slightly smaller and more intense than the southern one, implying that Saturn's magnetic field is not equally distributed across the planet. It is slightly uneven and stronger in the north than the south. As a result, the electrically charged particles in the north are accelerated to higher energies as they are fired towards the atmosphere than those in the south. This confirms a previous result obtained by the space probe Cassini, in orbit around the ringed planet since 2004.
Saturn is best known for its spectacular ring system. It was once thought to be unique, but in recent years, ring systems of various sizes have been discovered around each of the other giant planets. Before the Voyager space probes were sent to Saturn, astronomers knew of only 6 separate rings around the planet. False color images, however, revealed that there are actually many hundreds of small rings. The gravitational forces of Saturn's inner moons produce the dark gaps between the rings. Saturn's rings are thought to be made up of countless small chunks of rock and ice, up to 1 meter in diameter. These particles are so close to Saturn, they cannot combine to form into a moon.
There have been many great discoveries about Saturn's enigmatic rings and smaller moons. Scientists believe that Saturn's rings are much older than originally thought. Previous missions gave them the impression that the rings were formed perhaps 100 million years ago by a cataclysmic impact of a comet into a large moon. Using a technique known as stellar occultation, scientists acquired evidence that the rings appear to be older because smaller moonlets are recycling themselves. This animation shows you how a stellar occultation works. By measuring the flickering of starlight as it passes through the rings, we are able to tell how thick the rings are or if there's a more solid moonlet in the way. The moonlets appear to be continually colliding into each other, shattering into ring particles, and then their gravity brings them back together to recreate new moonlets. Scientists now believe that the rings may be as old as the solar system itself, 4.5 billion years old.
The recent equinox on Saturn has produced features in the planet's rings that have excited members of the Cassini mission team. For a week in August, the NASA spacecraft snapped photos of the rings when light from the sun shined exactly edge-on. It's the extent of the ruffles, bumps, shadows, and temperature changes the images show that have Cassini's scientists marveling.
We always knew that the structure in that flat two-dimensional pancake would be very complex when we got to look at it. So that wasn't too big a surprise. But that extra third dimension, I think, surprised everybody who took a look at it. And not just that it's there, but the extent of that third dimension. Sure, you could expect, waves going by that would maybe add a few feet here, a few feet there. But we're talking about structures that are miles, stretching miles above the rings. And things of that magnitude were beyond our expectations.
Since Saturn's year is about 30 times longer than ours, the ringed planet's equinox happens approximately once every 15 Earth years. This Saturnian equinox was the first captured by the Cassini orbiter.
In the case of Mimas, we see a crater on Mimas that's about 40% of its diameter. A little larger, and that would have been enough to shatter the object. And of course, we wouldn't see the crater then, because it would reassemble like a kind of a giant ball of sand. And in the case of Tethys, there's another very large crater, even larger than the one on Mimas. But in that case, notice the floor is now rounded out so that it is curved as the rest of the object's limb is. In the case of Dione, you'll notice that most of the surface is pretty bland. And only in this one region near the trailing hemisphere do we see a lot of detail on the surface. Here we see a lot of crisscrossing faults with wispy bright markings around them.
Cassini has also had its first close look at Iapetus, a satellite with one face as black as asphalt and the other as white as newly fallen snow. Bisecting Iapetus's dark side, Cassini has discovered an incredible ridge of ice that runs over 800 miles along the moon's equator and contains mountains 3 times as high as Everest. Elsewhere on Iapetus, Cassini's cameras capture the aftermath of a huge landslide that partially obliterates the floor of a great basin, ringed by walls of ice over 9 miles high. Later flybys of Iapetus will bring us views up to 100 times sharper. The images are wonderfully clear and reveal what may be a denizen from the far reaches of the outer solar system that has been captured by Saturn. Such objects have been described by some as dirty icebergs. Indeed, several of Phoebe's craters lend evidence to this scenario, for they show darker surface material which has slid down the walls of craters to reveal bright ice underneath.
The Odyssey started back in 1997 with the launch of the Cassini-Huygens mission, the most ambitious of its kind. After a 7-year journey, it reached Saturn, where its aim was to investigate in detail the giant gas planet and its moons. 62 have been counted so far. One of them in particular is of interest to astronomers.
Saturn has the jewel in the crown, namely Titan. Titan is the only moon with an atmosphere, really, that in any way resembles the Earth.
It is impossible to see through this atmosphere composed primarily of nitrogen. That's why scientists sent Huygens to investigate. Designed to collect data during its descent, the Huygens probe survived the landing and opened up a whole new world to mankind.
We saw landscapes that really resemble what we have on Earth. Huygens landed on a dry riverbed, a dried-out lake. What this picture shows is an important fluvial activity, erosion like on Earth. Pebbles of water ice are carried by this liquid, so what the picture suggests is complete fluvial activity. The liquid on Titan's surface is not water like on Earth, it's methane. There are methane rivers, methane lakes. We have counted more than 1,000 lakes, and sometimes it rains on Titan. It rains methane and sometimes ethane too. The existence of methane means there is a complex organic chemistry, and one of the objectives of this mission is to try to understand how complex this organic chemistry is.
Data sent back by Cassini suggests methane is not the only liquid on Titan. Scientists believe the core of this moon is made of rocks and oceans of water mixed with ammonia. Ammonia allows water to stay liquid at very low temperatures. Cassini also told us a lot about another of Saturn's moons, Enceladus. A small moon located in Saturn's outermost ring, it is a fascinating place. The Voyager missions back in the early 1980s had already provided some information about Enceladus, especially concerning its wide range of terrains. Cassini found out more.
When we flew really close, we found that, yes, there was an atmosphere at Enceladus, and the camera found cracks on the surface of Enceladus, and there was water vapor coming out from the surface of Enceladus. If we've got this water vapor plume coming off from the South Pole, the implication is that there's a heat source in the inside of Enceladus. And that's really very surprising because it's very small. And you would have thought that it had cooled down from when it first formed. And so there's a heat source that we just don't understand at the moment.
The plumes contain water and organic chemicals. This indicates that, like for Titan, there must be liquid water inside Enceladus. This is a major finding.
People have searched on Mars for water. They've searched on our moon to be able to find water as well. What we didn't expect to find was there was water filling the Saturn system, and there's essentially water everywhere.
We need to revisit all the models which say that it's impossible to find liquid water beyond 5 astronomical units or the distance to Jupiter. Now we need to extend the so-called habitable zone to Enceladus. That's 10 astronomical units. That means as far as Saturn. It changes everything. If liquid water is found throughout the solar system, then we have to start over in our quest for life and habitable zones in the solar system.
Initially scheduled to end in 2008, the Cassini-Huygens mission has been extended until 2017. That gives us another 7 years to investigate Saturn, a planet we knew virtually nothing about before. The goal is not only for astronomers to collect more data about the ringed planet, but also for scientists to find out more about the Earth we live on.